So today we are going to look at the CPU's components. Now this is still part of the 1.1.1 subtopic architecture of the CPU. So I've got a picture of the specification here of 1.1 systems architecture. Now so far we've covered the purpose of the CPU, the fetch execute cycle. Now we've covered what happens in the fetch execute cycle. Now today we will cover the common CPU components and their function, looking at these different components. Now here we have the arithmetic logic unit, or the ALU. So the ALU is a component inside the CPU that carries out a mathematical calculation. Now it performs logical operations and it is used during the fetch, decode and execute cycle, or the FE cycle. Now a quick recap. We said that in the FE cycle, data and instructions are fetched from memory. We also said that data and instructions are decoded and translated. And then we also said that the instruction is executed and carried out. Now here I've got a diagram of the ALU, or the arithmetic logic unit. So we said that it performs calculations, or it carries out calculations. Now calculations could include 5 plus 3 or 20 times by 9, something very simple. Now we also said that it performs logical operations. Now logical operations could include and, or, and not. Now we will cover this in another topic, so we don't need to worry about this for now. Now here, the control unit, or the CU. Now the CU is a component inside the CPU. It sends control signals to coordinate the flow of data. It decodes instructions and it runs the fetch execute cycle. So this is the decode stage. So here we have cache. Now cache is memory that holds frequently used data and instructions. Now it is also memory that has faster read and write speeds than RAM. Now cache is also memory that is located on board the CPU. Now here we said that memory has faster read and write speeds. Now cache has faster read and write speeds than RAM. That means that when the CPU has to access an instruction or data from cache, it will be much quicker to access the instruction or read the instruction, and it will be much quicker to store the instruction or data in cache than RAM. Now here I've got a mock scheme definition of cache. So cache is essentially just memory that contains recently or frequently used instructions and data. Memory that has a faster read and write speed than RAM, and memory that is closer to or on board the CPU. So again, this read and write, accessing and storing. Now this is the exact definition for cache, so I suggest you learn this. Now here I've got another diagram of the CPU. Now this has the different components that we just looked at. So the ALU, the CU, and cache. Now the ALU, we said, carries out calculations. We said that it performs logical operations. Now the control unit, we said that it sends control signals to coordinate the flow of data within the CPU. Now the control unit also decodes instructions or translating them. And then we also said it runs the FE cycle, or the fetch, decode, and execute cycle. Now here, cache is memory that holds frequently used data. And instructions. Now we also said that is memory that is located on board or close to the CPU. And we said that it is memory that has faster read and write speeds than RAM. Now here, when I've said this first point, memory that holds frequently used data and instructions, let's say you use Google a lot. Now the computer will recognize that and it will store Google into cache. So the next time you open it, or whenever you open it, is much quicker to access the app than storing it in RAM each time. Now here we got the registers. Now registers are essentially just temporary memory or storage locations inside the CPU. Now it is used for a single specific purpose. So registers have faster access speeds than RAM or secondary storage. Now we can ignore secondary storage for now because we haven't done this yet. Now here I've got a mark scheme. Well, I've got a question for the registers. State what is meant by the term register. Only 2 marks, so 2 points. So we said that it was temporary memory location inside the CPU. Now we also said that it is located we also said that it has faster access speeds. than RAM. So those are 2 points. So let's have a look at the mark scheme answer. So this is the definition of registers. So we also can say that it is used for a single specific purpose. Now here I've got another mark scheme, and I've got another question that you guys could try. Complete the table by writing the missing definition or name of each of the common CPU components and registers. Now we haven't done registers yet, so we can ignore this. We can ignore these two definitions and components. So here we have the CU. So we said that it sends control signals to coordinate the flow of data and instructions, but a sense of data. Now that's enough for that 1 mark there. Now here, what do we know that performs mathematical calculations and logical operations? Obviously that is the ALU, the arithmetic logic unit. Now this is 2 marks because we got rid of these 2 definitions and components. So this is for 2 marks. So now we have the mark scheme answer. Now we said that the control unit, it sends signals to coordinate the flow of data. So you can also say it synchronizes or controls the flow of data or the processor or the hardware or the FE cycle. There's a lot of things you could say. Now this next point, it decodes instructions just as we said, and it also runs the fetch, decode, and execute cycle. Now here we have the ALU, the arithmetic logic unit. Now we said that it performs the mathematical and logical calculations. Now here we got the guidance for the examiner. Now it says that the control unit doesn't, sending signals to components is not enough. Now they want you to state a purpose with it. Now that's why we also included this part here, the flow of data. Now why does the control unit send signals to different parts of the CPU? It is because it has to coordinate the flow of data. I hope you guys understood what the different components of the CPU do.